Sarah's fighting a sinus infection. Her doctor prescribed a nasal spray and an antibiotic to fight the infection. The active ingredients in milligrams remaining in the bloodstream from the nasal spray N of T and the antibiotic A of T are modeled in the functions below, where T is time in hours since the medications were taken. Determine which drug is made with a greater initial amount of active ingredients. Justify your answer. Sarah's doctor told her to take both drugs at the same time. Determine algebraically the number of hours after taking the medications when both medications will have the same amount of active ingredients remaining in her bloodstream. Okay, so to determine the initial amount of active ingredients, well, what does it mean to be at the initial? Like, what moment in time is that? So initial implies that t is equal to 0. So if that's the case, we're going to find out what is the value of n of 0 as well as the value of a of 0. So n of 0, what will that be? It will be 0 plus 1, so that's 1, over 0 plus 5, so that's 5, and then plus 18 over 0 squared plus 0 times 8 plus 15, so that's just 15. And this is the same thing as 1/5 plus 3 goes into both 18 and 15. So it will be 6/5. So we have 7/5. And for a of 0, we are going to plug in 0, so it's 9 over 0 plus 3, so it's 9/3, or this is just 3. So looking at this, a of 0 is greater than n of 0. So therefore, we can conclude that the antibiotic has greater initial active ingredients. Okay, and then the second part of the question says determine algebraically the number of hours after taking a medication when both medications will have the same amount of active ingredient. For that, I'm going to change colors now. So we want to determine at what moment in time will n of t equal to a of t. So let's write that out. So we have t plus 1 over t plus 5 plus 18 over t squared plus 8t plus 15. And that is equal to 9 over t plus 3. So this problem, looking at this, I notice immediately that the denominator in the second fraction on the left is factorable. Right, this becomes 18 over t plus 3 and t plus 5. And in order for us to solve for the unknowns, what we're going to do is we are going to create common denominators. So I'm going to use another color. So if you notice, the fraction on the left, the denominator there is missing a t plus 3. So we'll multiply the first fraction by t plus 3 over t plus 3. The fraction on the right is missing a t plus 5, so I'm going to multiply by t plus 5 over t plus 5. And so the problem now, the fraction on the left will now become t plus 3 times t plus 1 plus 18 all over t plus 3 times t plus 5, because I've created common denominators, and this is equal to 9 times t plus 5 over t plus 3 times t plus 5. Because I have the same denominator both on the left and right, I can just cancel them. So I have t plus 3, t plus 1, plus 18 is equal to 9 times t plus 5. I will now FOIL the left-hand side and distribute the right-hand side. So I have t squared plus 4t plus 3 plus 18 is equal to 9t plus 45. I will now try to combine like terms. Subtract both sides by 9t. I end up with t squared minus 5t. Subtract both sides by 45. I will end up with 24. So minus 24 is equal to 0. And this thing turns out to be factorable. So two numbers that multiply to negative 24 but add to negative 5, what would that be? That would be x minus 8 and x plus 3. Sorry, that's a t, not an x. Since we're dealing with time, and this is after 0, the only answer that makes sense is t is equal to 8. So after 8 hours, the antibiotic and the nasal spray will have the same amount of active ingredients. So let me see if I need to write a statement there. Determine algebraically the number of hours after. Nope, I don't need to write a statement. So that's pretty much it.